Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about hypothesis testing part 2. Luckily for you folks at home, we've got a very special guest for you. He's a rising star in the HTI community. He's both the null and the alternative hypothesis. He's Professor Jay Cho.
Thank you.
Hey Jay, how's it going?
Going good, how are you?
I'm pretty good. How's your hypothesis test investigator training going?
It's going good. I'm learning a lot. Yeah, I'm really enjoying my new job, career. I think being a hypothesis testing investigator is my true calling.
Wow.
Yeah.
I haven't seen you this excited since the Chobucks lemonade stand. Those are good times.
Good times. Chobucks lemonade. You know, it's a thing of the past. Now I'm all about hypothesis testing.
Hey Jay, I'm wondering, what exactly is a hypothesis anyways?
In statistics, a hypothesis is a claim or statement about a property of a population.
So these claims that we discussed last time, college students sleep less than 7 hours a night, more than 40% of Californians speak a second language. These are examples of hypotheses?
Hypothesis. You know, Roger, the plural of hypothesis is hypotheses.
Whoa, Mr. HTI, you really did learn something. Yeah, so what exactly is a hypothesis test?
A hypothesis test, or test of significance, is procedure for testing a claim about a property of a population.
Oh yeah, I remember last episode we saw many different types of claims, like claims involving two means with independent samples, or claims involving matched pairs, or claims involving two proportions.
Exactly.
You said there was one process that we could use to, test all these different claims.
Exactly. This process is called hypothesis testing.
Why don't you teach our viewers about this process of hypothesis testing?
That's right. They say the best way to learn something is try to teach to other people,
Who said that?
They, obviously.
Oh, okay. Anyways, what's the basic structure of a hypothesis test, Jay?
Well, roughly there are 5 steps to hypothesis testing.
What does set up two contradictory hypotheses mean?
A claim is usually given in words. So first, we want to translate it into mathematical statement.
Okay.
Then we want to also come up with the opposite statement.
Oh, maybe we can explain this using a claim like, college students sleep less than 7 hours a night on average.
Are they still sleeping less than 7 hours?
Man, I wish I could sleep at least 7 hours. Anyways, how are we going to translate this claim into a mathematical statement?
Well, first of all, is this claim about mean or proportion?
Well, we saw the words on average, so it seems like it's a claim about the mean.
Right. However, even if I didn't see the word mean on average, I could figure out this is a mean situation.
Why would that be the case?
Because we're measuring the number of hours they slept.
Oh, we're measuring the amount of time they slept, not whether they slept 7 hours or not.
Exactly. So we have a quantitative data set.
Oh, and it's not categorical.
Exactly. That's why we're not doing proportion, but the mean.
I see. So if I want to translate this into a mathematical statement...
Right. How would you do that?
Well, we want the mean to be less than 7. So would it be x bar less than 7?
Not exactly.
I thought the symbol for mean was x bar.
Well, x bar is a symbol for sample mean. Here we're testing about population mean.
Oh, do we always use population mean?
Well, when testing for mean, yes. But remember, hypothesis testing tests claims about population parameters. Remember last episode, we've been using mu's and p's all over because these represent population parameters.
Oh yeah, that's right. I remember all of our examples had mu's and p's in them.
Exactly.
So does that mean that we never use x bar, sample mean?
Well, we need to collect a sample to test our claims, so we'll be seeing x bar soon enough.
Oh, I see. So a customer comes to you with a claim to test. You set up contradictory hypotheses. You go out and collect sample data in order to prove that the statement is true or false?
Prove, yes, kind of. But remember, we're not proving anything with certainty. We're just making statement in terms of probability.
Oh, Oh, yeah, I remember now. You managed to find the career that pays you the big bucks to say, maybe.
Maybe.
So our claim was college students sleep less than 7 hours a night on average. This translates to mu less than 7, right?
Exactly. The claim is mu is less than 7.
Now what?
We're going to take this claim and we're going to create null hypothesis H0 and the alternative hypothesis HA.
I see H0. Why are you calling it H0?
Well, H0 and H0 are the same thing.
Oh, okay. So what's the difference between the null hypothesis and the alternative hypothesis? How do we know which is which?
The alternative hypothesis HA can have the symbols less than, greater than, or not equal to. These are signs that don't have equal sign.
What about the null hypothesis?
Well, alternative hypothesis and null hypothesis, they're opposite of each other. Since alternative hypothesis has non-equal signs in it, the null hypothesis has equal signs in it. So, if alternative hypothesis is mu less than some number,
the null hypothesis should be the opposite. So that should mean that mu is greater than or equal to some number.
Exactly. And when the alternative hypothesis is mu greater than a number,
then, again, being the opposite, it should be mu is less than or equal to a number.
and finally, when mu is not equal to a number,
Then mu must equal the number. Oh, I think I get it. We just set them up as opposites all the time.
exactly.
Let's get back to our original example.
Notice that our original example, alternative hypothesis was mu less than 7.
That means that our null hypothesis should be the exact opposite of that. So that should be mu is greater than or equal to 7, right?
Well, just to let you know, some books use only equal sign for the null hypothesis.
What? Why is that?
Because hypothesis testing use this thing called the rare event rule. If, under a given assumption, the probability of a particular observed event is extremely small, we conclude that assumption is probably not correct.
Oh, you mean a rare event like you dating someone that's not a bear?
I like our shapes and sizes and dimensions.
Right. So what does the rare event rule have to do with our null and alternative hypothesis?
If, under a given assumption, a given assumption is the null hypothesis, we need to assume that the mu is equal to a specific number, so we can do calculations based on that. That's why the null hypothesis needs to have an equal sign.
Oh, so our assumption is the null hypothesis H0, and it must have an equal sign in it.
Exactly.
This means we're assuming mu is equal to 7. What about the next part where it says a particular observed event?
If, under a given assumption, the probability of a particular observed event. Well, particular observed event is the sample that we collect.
Oh, so we're going to use stats to determine whether our sample was unusual or not?
Exactly, but we're going to have to explore that in the future.
Oh, okay. Save your disappointment.
And there's one more thing we need to do after finding the null and alternative hypothesis.
What's that?
We're going to have to label the original claim as one of those two. So in our example, do you think our original claim is H0 or HA?
Okay, so our claim was college students sleep less than 7 hours a night on average. I see those words less than, and that corresponds with the alternative hypothesis, mu less than 7. So that would be our original claim, right, Jay?
Exactly.
Cool. Why don't we look at another example?
Okay, let's say the claim was 60% of the California community college students have experienced food insecurity. Wow, that's a lot higher than I thought. Did you know that PCZ has food pantry on campus?
That's on the second floor of the CC building, right? Campus Center?
Right. The Lancer Food Pantry offers healthy, non-perishable food at no cost.
They just need to bring a valid student ID, right?
That's right.
So, 60% of California community college students have experienced food insecurity. Is that a mean or a proportion?
Well, it's a proportion. First of all, it's categorical data. Either they have experienced food insecurity, where they're hungry but they didn't have anything to eat, or they didn't experience the food insecurity. Also, the percent sign gives a clue that it's a proportion.
Oh, okay. So let's look at our original claim again. Our claim was 60% of community college students have experienced food insecurity in the past year. That seems to be a statement of equality, so I think that claim translates to P is equal to 0.60.
And is this the null or alternative hypothesis?
Well, it contains an equal sign, so I think that should be the null hypothesis. So the null hypothesis would be P equal to 0.60.
Well, in that case, what would be the alternative hypothesis?
The alternative hypothesis needs to be the exact opposite. So the alternative hypothesis should be P not equal to 0.60.
Okay, next we have to figure out what's the original claim. Don't forget to label that.
Well, the original claim has equality in it, so the original claim should be the null hypothesis.
Excellent, I think you got it.
Give me one more.
Okay, Smarty Pants, here's the tricky one. Claim. In the year 2016, 33% of the adults aged between 25 and 29 lived with their parents. Test the claim that current percentage is different from the year 2016 percentage.
You still live with your parents, don't you, Jay?
What? First of all, the claim is about adults aged between 25 and 29.
Haven't you been 29 for like the last 15 years?
Secondly, I don't live with my parents live with me.
Oh, okay. Let's take a look at this claim. Our claim is, in the year 2016, 33% of adults aged 25 to 29 live with their parents. Test the claim that the current percentage is different from the year 2016 percentage. So the 33% seems to indicate we have a proportion, right?
Yes. Are there any other clues?
Well, it seems like either you live with your parents or you don't. I mean, I'm imagining survey questions like, do you live with your parents? Which is yes or no response. So we would be looking at a proportion of yes responses.
Exactly. What else do you see?
I see that the phrase is different from seems important. If two percentages are the same, then they are equal. So if two percentages are different, then they are not equal?
What is not equal to what? How would you write the claim as a mathematical statement?
We're talking about proportion P. So the claim translates to P not equal to 2016?
2016? Roger, we're talking about proportion. Proportion can be only between 0 and 1, which corresponds to 0% and 100%. 2016 is way bigger than 1. It's just the name of the year.
Oh, right. Well, P is not equal to 2016 is technically not untrue. So anyways, what I meant to say was P not equal to 0.33.
Exactly. You almost fell for the trick where they referred to a number that was given previously.
Yeah, they almost got me there.
Wait, who's they?
You're they.
So is this a null hypothesis or alternative hypothesis?
Well, I see that this claim has a not equal to, so that seems to indicate that it's an alternative hypothesis.
Okay, in that case, what will be our null hypothesis?
Well, our null hypothesis has to be the opposite of the alternative hypothesis. So in this case, our null hypothesis is going to be P equal to 0.33.
So which one of these is the original claim?
P not equal to 0.33 is the original claim.
You got it.
Awesome. So to summarize, we start off with an original claim. The first thing we need to do is we need to translate that claim into math symbols. After you've translated that claim into math symbols, you got to figure out if it's the null or the alternative hypothesis. These two null and alternative hypotheses are set up to be opposites with each other. The null hypothesis must have an equal sign in it, so it could be equals, greater than equals to, or less than or equal to. The alternative hypothesis is set up to be the exact opposite. The alternative could be not equal to, less than, or greater than. Once you've set up the null and alternative hypotheses, then the last thing you need to do is you need to label which one of these two is the original claim.
Wow, that was an excellent summary, Roger.
Thanks. I've been working on my summary game. Anyways, maybe next episode you could teach our viewers about the rest of the hypothesis testing process.
Okay. Oh, look at the time. Shoot, I gotta run. I gotta go to my class.
But your class doesn't start for another hour.
Yeah, I know, but I gotta do my pre-reading before my class.
Pre-reading?
Yes, I want to read ahead before class starts.
Why would you want to do that?
There are some benefits of pre-reading. First, I know what the instructor is going to be talking about.
Oh yeah, there are times where I've wandered into class late and I'm like, what the hell is going on?
Exactly. And second, I want to get familiarized with the terminologies that I've never seen before.
Oh yeah, sometimes the professor keeps saying this word and you think it means one thing and it turns out he's saying this totally other word.
Exactly. And then thirdly, when seeing for something for the second time, it makes a lot more sense than the first time.
Oh yeah, sometimes the first time I see something I'm like, what? But the second time I see it I'm like, oh.
Right, so there are a lot of benefits. Do you think you're going to be do your pre-readings too, Roger?
Jay, you've convinced me to do pre-reading. Except, I'm not really much of a reader. If only there was a video or something I could watch.
Yeah, if only they create this video so students can watch it before coming to class.